Let's solve this question 22 of 2026 tutorial sheet, which is the April tutorial sheet. The question was reading: when benzene reacts with 1-chloro 2,2 dimethylpropane, which is also known as neopentyl chloride, in the presence of aluminum chloride, the major product is 2-methyl 2-phenyl butane, not 2,2 dimethyl 1-phenyl propane, which is also known as neopentyl benzene. Explain these results. Okay, so this is quite an interesting question. So you can find a way to explain this result by doing what is known as a reaction mechanism. By performing a reaction mechanism, you'll be able to explain, but without a reaction mechanism, it will be very hard for you to explain these results. Alright, so let's get into it. So we have the benzene, which is here. Alright, so this benzene had to react with 1-chloro 2,2 dimethylpropane. So we have propane there, so meaning that it is something with 3 carbon. Okay, so at position number 1 there is chloro, so this is our position 1. There is a chlorine there. Okay, then at position 2 we have 2-methyl, so at this position here we have 2-methyl. Here we have 2-methyl. Okay, so this is how the reaction was, and this was reacting in the presence of aluminum chloride. Okay, so now let's see how we can do the reaction mechanism for this reaction. So the first thing is that from this reagent to be given, or these reactants rather, we know that this chlorine is a good leaving group, so it can actually leave. Okay, so this is what we are going to have. So this chlorine can leave, so we'll have the benzene being like this. So when this chlorine leave, we have a carbocation at that point, so we're going to remain with this, with a carbocation at this point. Okay, so this is what we are going to have. In the presence of aluminum chloride, like that. So this double bond now can attack this carbocation. So this double bond can attack this carbocation. But mind you, if this double bond attacks this carbocation, the product which is going to be formed is the minor product, because this is a primary carbocation. So what we need to do here, actually, it is to perform what is known as a methanide shift. Okay, so we can do a methanide shift. This is the minor product which is not produced. That product they have told us not to produce. So we need to do a methanide shift for us to get the major product. The major product will be formed from a carbocation which will be at the secondary. Okay, That is where the major products will be formed. So let's do a methanide shift. So we do a methanide shift. So we have this carbocation here. So it's like this. Like that. So the carbocation is there. If we do a methanide shift, we are simply shifting this group, which is here. Oh, there's another branch here. Okay, so we're just shifting one methyl to this position, then the carbocation will come to this point. So this is what you're going to have. So methanide shifts. Methanide shift is going to shift this carbocation from that point. So we're going to have this. So this methyl will come to that point. Then we are going to remain with this. Then with the carbocation there. So this is a methanide shift. Then this secondary carbocation is the one we are going to use to react with benzene. Okay, not the primaries, because the primary is not what we want to produce. The primary actually will produce this 2,2 dimethyl 1 phenyl propane, because it is the one which has a primary carbocation, and the primary carbocation will form unstable carbocation. So we need to perform a methanide shift for us to form a stable carbocation, then we can do the reaction. So this carbocation will replace it with a stable carbocation. Okay, so let's now do this. So we have this group with a carbocation at that point. So this double bond now can attack this carbocation. Once that occurs, this is what you're going to have. Okay, so we're going to have this ring. So now the double bond has been broken. Then we are going to attach this. Okay, like that. Then we'll have, since the double bond was broken, we have a carbocation at that point. If we decide to put this group at that point, meaning that the carbocation would have been here. Okay, so the next thing here now, we can use the chloride which left. So here we still have a hydrogen, so we can deprotonate this group. So we can bring the chloride which left. It has lone pair of electrons, so it can come and deprotonate this hydrogen. Then the bond here will break, reforming the double bond at that point. So what we are going to have is actually this. We have a phenyl group now, with a double bond there. The positive charge has been neutralized now because we have formed a double bond. Then we'll have this. Okay, so this is now our product. This is our product. So apart from this, you can see that we're also forming something. That's chloride. Apart from this, that chloride can also react with the hydrogen. So this can also form hydrogen chloride. So we are going to say hydrogen chloride is also part of our reagent, our product rather. Okay, so that is how you are going to form these products. So these are actually the products which are formed, so of which our main interest is this product. So let's just try to see if you have formed the right product. So I'll try to get rid of this. So the product you formed is this group. So it is actually this product, which I'm just trying to write it here so that we can name it. We can write its nomenclature. Okay, so let's name this product which we've formed. So let's see. So this is the phenyl group. So we're going to count. Let's count 1, 2, 3, 4. Or we can say 1, then this will be carbon number 2, there, carbon number 3, then carbon number 4, like that. So now we can name this. We can name now this product. So you can see that at carbon number 2, we have this group which is a methyl, and also at this same carbon number 2 we have this group which is a phenyl. So what will be these products? What will be the name? So at carbon number 2 we have a methyl, so it will be 2-methyl, 2-methyl. Then at this same carbon number 2 we have a phenyl, so we have this methyl and also this phenyl. So again 2, 2, so 2-2, then we're going to say phenyl. Okay, let me just get rid of this part. Right, so 2-methyl, 2-phenyl, then 1, 2, 3, 4, so this is butane. So the product you formed, it is 2-methyl, 2-phenyl butane. So this is our product of interest. So the question was reading, when benzene reacts with that, in the presence of aluminum chloride, the major product is 2-methyl, 2-phenyl butane, of which we've produced. So this is the same product we've formed, and not that one. So the reason here actually it is just because of that methanate shift in the quest for forming the stable cation. The stable compound or the major product must be formed from the stable carbocation, which is a secondary carbocation instead of a primary carbocation. So this is why we had to produce the major product from a secondary carbocation, just about the stability, because the product which is formed from a stable carbocation, it is actually a stable product. So this is what we need to understand. Thank you for watching. Don't forget to like, share, and also subscribe.